Welcome back to CS Connect series. In this video, we are going to discuss about summations concept. Actually, this is a continuation of sequence only. In the sequences video, the previous video, we actually generated sequences for normal functions, then for recurrence relations, and we got a set of terms right. After getting those terms, if there is a scenario where you want to compute the sum of all those terms or product of all those terms, what will you do? For that we will have a set of formula, and that is what we are going to discuss in this particular video. Since there are different kinds of practice problems here, I thought this topic can be taken as a separate video. We will start with the summation concept. Addition of the terms inside that sequence is what we call as summation. The summation notation used to express the sum of the terms am plus 1 till an from the sequence an will be j is equal to m to n aj. So this is the initial term and this is the final term. These are different ways of representing the summation notation. In whichever way they give, it is just telling you it is a sum from j is equal to m to j is equal to n of aj. This is the meaning of all the three notations. A large uppercase Greek letter sigma is used to denote summation. The variable j is called the index of summation. The index of summation runs through all integers starting with its lower limit m and ending with its upper limit n. So m and n are lower and upper limit respectively. The choice of letter j as the variable is arbitrary. You can either use j or I or k. These three variables are usually used as index. The usual laws for arithmetic apply to summations also. When a and b are real numbers, they have given summation of j is equal to 1 to n, a of xj plus b of yj. How do we actually compute such sum? We have sum here, so this plus can be taken out. This particular summation is applied to the axj component as well as for byj component. When you have summation of axj plus summation of byj, this a is constant throughout, so it can be taken out. Similarly, b can be taken out. This is how they have presented in form of a into summation of xj plus b into summation of yj, where x1 to xn and y1 to yn are real numbers. Sometimes it is useful to shift the index of summation in a sum. This is often done when two sums need to be added but their indices of summation do not match. Let's have a sum. Summation of j is equal to 1 to 5 j square, but want the index of summation to run between 0 and 4 rather than from 1 to 5. So here the limits are given as j is equal to 1 to 5. Sometimes when you want to compute for this kind of cases, if one is going to give 1 to 5 and the other summation is running from 0 to 4, at that time we need to adjust. In those situations, how can you handle such problem? To do this, let's take k is equal to j minus 1. Then the new summation index runs from 0 to 4. When j is equal to 1, k will be 1 minus 1 which is equal to 0. When j is equal to 5, k will be 5 minus 1 which is equal to 4. Now what is the limit of the new index k? It is 0 to 4. The term j square becomes k plus 1 the whole square. What is j here? We can have it as k plus 1. So from this particular expression, we are bringing it to this form. So when we have a computation called j square, now this will be k plus 1 the whole square. Why are we actually working with k? Because now the index will be k for summation. So we are also changing this particular variable to k. Summation of j is equal to 1 to 5 on j square is equal to summation of k is equal to 0 to 4 on k plus 1 the whole square. For j is equal to 1 to 5, 1 square plus 2 square plus 3 square plus 4 square plus 5 square. This is going to give you 55 only. Here it is k plus 1. So 0 plus 1 is 1 square. 1 plus 1 is 2 square, 2 plus 1 is 3 square, 3 plus 1 is 4 square. When k is equal to 4, this will become 4 plus 1 which is equal to 5 square. So both will give the same answer only. This is the way we have to shift the index when we want to work out with other sums where the summation indices do not match. Now we'll see the concept of double summation. Double summations arise in many contexts. In programming context, we can compare this to nested loops, a loop inside a loop. When you have double summation, this sum should be computed first and this sum should be computed next. To evaluate the double sum, first expand the inner summation that has index j. Now let's understand this in a better way. They have given as I into j here. Let's keep I as it is. What are the possible values of j here? We have j is equal to 1, j is equal to 2, j is equal to 3. When we have I here, this will be steady here as it is. What is the value of j for the first term? It is 1. What is the value of j for the second one? It is 2. For the third one, it is 3. Now what is I into 1? It is I. What is I into 2? It is 2i. What is I into 3? It is 3i. Now you have to sum up all these three. I plus 2i will give 3i. 3i plus 3i will give 6i on the whole. Now you have to continue by computing the outer summation. So this will be 6 into 1 plus 6 into 2 plus 6 into 3 plus 6 into 4. So 6 into 1, 6 into 2, 6 into 3, 6 into 4. Remember, this inner loop is running for 3 values from j is equal to 1 to 3. The outer loop is running for I value from 1 to 4. So what is 6 plus 12? It is 18. 18 plus 18 is 36. 36 plus 24 will be 60 on the whole. To use summation notation to add all values of a function or terms of an index set where the index of summation runs over all values in a set. We saw with respect to numbers here. This is with respect to the set. Here we have element small letter s that belongs to the capital letter set s, and we have a function f of s. This represents the sum of values f of s for all members s of s. This is with respect to set. They are saying this set is having capital S is equal to 0 to 4. At a time, small s will have 0, small s will have 2 and small s will have 4. So instead of running from 1 to 4, 1 to 3, here we are running for these 3 elements. So what is the function here? Just s. So when s is equal to 0, only 0 is taken. When s is equal to 2, only 2 is taken. When s is equal to 4, only 4 is taken. So we are summing up all these 3 elements and bringing it to 6. So instead of having indexes that are running through continuous numbers, we are going with the values inside the set. Now we will see about geometric series. Sum of terms of a geometric progression. So we saw about geometric progression in the previous video sequences. Now we will see the summation. If a and r are real numbers and r is not equal to 0, because r is going to be the common ratio, you cannot keep it as 0. Once you have 0 in r, you will have nothing to compute because a into 0 will give 0 for every term. This will run from j is equal to 0 to n a into r power j. So they have actually explained how this particular formula has come in certain books. I am not getting into the detailed explanation. When r is equal to 1, we have n plus 1 into a. When r is not equal to 1, this will be the formula. A into r power n plus 1 minus a divided by r minus 1. Now we will see about some useful summation. They have given the summation of the geometric progression here. When you have 1 to n sequence, it is given by n into n plus 1 divided by 2. Actually, I explained all these things in mathematical fundamentals video. What about k square? We have n into n plus 1 into 2n plus 1 divided by 6. For k cube, we have a formula. Then for 2 infinity value, it means from 0 to infinity it has to run. When it is x power k, where absolute value of x is less than 1, we have 1 divided by 1 minus x, and when it is k into x power k minus 1, at that case we will have 1 minus x the whole square in the denominator instead of 1 minus x. Infinite series are usually studied in a course in calculus. Sometimes discrete mathematics deals with infinite collections of discrete elements. So for that purpose, we are also including them in this particular concept. Now we are getting into the practice problem session. The first problem. What is the value of the sum? 2 power j plus 1 minus 2 power j. It has to run from 0 to 8. So let's take the first value 0. 2 power 0 plus 1 minus 2 power 0. 2 power 1 minus 2 power 0. 2 minus 1 will give you 1. What about j is equal to 1? 1 plus 1 will give 2. So 2 power 2 minus 2 power 1. This will be 4 minus 2, which is equal to 2. Then we have j is equal to 2. This will be actually j plus 1 and this will be j. 2 plus 1 is 3. So 2 power 3 minus 2 power 2 will be 8 minus 4, which is equal to 4. Then we have 2 power 4 minus 2 power 3, 16 minus 8, which is equal to 8. Then 2 power 5 minus 2 power 4, 32 minus 16, which is equal to 16. Then we have 2 power 6 minus 2 power 5, 64 minus 32, which is equal to 32. Then we have 2 power 7 minus 2 power 6. This is 128 minus 64, which is equal to 64. Then 2 power 8 minus 2 power 7. This will be 256 minus 128, which is equal to 128. Then we have 2 power 9 minus 2 power 8. This will be 512 minus 256, which will be 256. Now you have to sum them together. 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128 plus 256. This will be 20, this will be 10, so it is 30. 128 and 32 will give 160 plus these two together will be 65. Then you have 256. So this is 190 plus 65 will have 255 totally. Altogether you will have 511 as the answer. So the summation value will be equal to 511. This series is telescopes. Each term cancels part of the term before it. We will see about this in the later part of this video. What is the value of the sum of terms of a geometric progression? Again we have the index running from 0 to 8. This time it is 2 into minus 3 power j. So we have this particular formula in geometric progression. So instead of running through all the values like in the previous sum, we are going to substitute it in the formula. So we have a is equal to 2, r is equal to minus 3, n is equal to 8 because this will be the n's value. They have given us 0 to n. Then we have n plus 1 value as 8 plus 1, which is equal to 9. So let's take the formula a into r power n plus 1 minus a divided by r minus 1. So what is a here? It is 2. What is r? It is minus 3. N plus 1 is 9 minus 2 divided by minus 3 minus 1. We will take 2 outside. So this will be minus 3 the whole power 9 minus 1 divided by minus 4. Now we can cancel them. This will be minus 3 power 9 minus 1 divided by minus 2. We have just cancelled only 4. The minus is staying as it is. Now what is minus 3 power 9? It is minus 19683 minus 1 divided by minus 2. This will be minus 19684 divided by minus 2. Cancel the minus in the numerator and the denominator. Overall you will have the sum 9842. Next problem. Compute each of these double sums. The inside index j runs through all of its values for each value of the outside index I. For I is equal to 1, for the first value you have to run j continuously. For j is equal to 1, for j is equal to 2 and for j is equal to 3 you have this. So what is I plus j? 1 plus 1, 1 plus 2 and 1 plus 3. 2, 3, 4. When I is equal to 2, what will be the case? This will be 2 plus 1, 2 plus 2 and 2 plus 3. This will be 3, 4, 5. Now you have to sum them together. What is 1 plus 1? It is 2. 1 plus 2 it is 3. 1 plus 3 it is 4. Sum all these together. This will give 9. Then 2 plus 1 is 3. 2 plus 2 is 4. 2 plus 3 is 5. If you sum all these together, you will get 12. What is 9 plus 12? Ultimately, you will have 21. Now, let's go for the second sum. When I is equal to 0, this will be j is equal to 0, j is equal to 1, j is equal to 2 and j is equal to 3. 2 should have I here and 3 should have j here. So, all the 2 will have 0 here and the 3 will have 0, 1, 2, 3. Similarly, when I is equal to 1, 2 into 1 will stay as it is and the 3 will be running from 0 to 3. Similarly, when I is equal to 2, 2 into 2 will stay as it is, 3 will be running from 0 to 3. In all these cases, understand one thing, j is running from 0 to 3 and I is running from 0 to 2. Now just find the sum. 0 plus 0 will give you 0. 0 plus 3 will give you 3, 0 plus 6, then 0 plus 9. Here we have 2 plus 0, 2 plus 3 is 5, 2 plus 6 is 8, 2 plus 9 is 11. Here it is 4, 4 plus 3 is 7, then we have 4 plus 6 which is 10, then we have 4 plus 9 which is 13 here. 0 plus 3 plus 6 plus 9 is taken here. 2 plus 5 plus 8 plus 11 is taken here. 4 plus 7 plus 10 plus 13 is taken here. 9 plus 9 will give you 18. 7, 15, this will be 26. 11, 21, 34. 34 and 26 will give 60. 60 plus 18 will give 78 on the whole. Let's go for two more sums. I is equal to 1, 2, 3 and we have j is equal to 0, 1, 2. Now what is here? Just I. So whatever value you have for I, that alone will stay. J is just used for looping through or iterating through the sum. What is 1 plus 1 plus 1? It is 3, this is 6 and this is 9. So 9 plus 9 will give you 18 ultimately. Now you have j running from 1 to 3 in the fourth sum and I running from 0 to 2. So when I is equal to 0, so here it is 1, 2 and 3. Anything multiplied by 0 will give you 0 only. What about I is equal to 1? 1 into 1, 1 into 2 and 1 into 3. So 1 plus 2 plus 3 will give you 6. And what about I is equal to 2? 2 into 1, 2 into 2 and 2 into 3. Now 2 into 1 will give 2, 2 into 2 is 4, 2 into 3 is 6. Altogether you will have 12. So 0 plus 6 plus 12 will give you 18 here also. Next problem, sum both the sides of identity k square minus k minus 1 the whole square is equal to 2k minus 1 from k is equal to 1 to k is equal to n and use telescoping to find. What is telescoping? We have a summation running from j is equal to 1 to n. We have aj minus 1 which is equal to an minus a0 where the terms will be a0, a1, an in the sequence of real numbers. This type of sum is called telescoping. If we just write out what the sum means, we see that parts of successive terms cancel leaving only two terms. Let's take this particular summation as a1 minus a0, then a2 minus a1, then a3 minus a2. So at a time, the term and the previous term will be coming here. But just find a1 and minus a1 will get cancelled. Then you have a2 and minus a2 that will get cancelled. Similarly, an minus 1 and minus of an minus 1 will also get cancelled. This one will get cancelled somewhere here. What is alone not cancelled? Minus a naught and plus an is not cancelled. So this is minus a naught plus an which is rearranged as an minus a0. So this sum is called telescoping. So previously when we had 2 power j plus 1 minus 2 power j, This is also the same way telescoping works. That's why they compared it to telescoping series. Now let's get into the first subdivision of the problem. A formula for k is equal to 1 to n in summation for 2k minus 1. The sum of the first n odd natural numbers is what they have asked. We use the hint ak is equal to k square. They are taking the first term here as an and the final term here as a0, which is in the form of an minus a0. So they are taking it as the solution of this particular telescoping series. So from this, what is ak? It is k square. We know 2k minus 1 is equal to k square minus k minus 1 the whole square. So instead of this particular term, we are substituting it with this particular term. So take this to be an term minus a0 term. So this k will be running from 1 to n. So when k is equal to 1, we have to take it for a0 as k minus 1, which is equal to 1 minus 1. That is what we do here. When considering an as k is equal to n, k square becomes n square, and that is what we do here. What is n square minus 0 square? It is n square. So the question runs like, use telescoping to find a formula for this particular summation. Summation of k is equal to 1 to n. 2k minus 1 can be equated to n square is what we have got from A. Now what about B? Read the question as, use telescoping to find a formula for k is equal to 1 to n k. We can use the distributive law to rewrite k is equal to 1 to n 2k minus 1 in terms of the sum we want. S is equal to summation of k is equal to 1 to n k. We saw something like axj plus byj. N square is equal to this particular equation. We have found it from A. Summation of k is equal to 1 to n 2k minus 1 can be written as summation of k is equal to 1 to n 2k minus summation of k is equal to 1 to n 1. Now since we have a constant 2 here, we are taking 2 outside and making this as summation of k is equal to 1 to n k minus summation of k is equal to 1 to n 1. Now this will be 2 into s minus what is summation of 1 to n? It is n only. When you have summation of k is equal to 1 to n 1, how will the summation work? When k is equal to 1, you have 1, plus when k is equal to 2, you have 1, plus when k is equal to n, you will have 1. How many number of 1s are here? N number of 1s are here. So the summation of k is equal to 1 to n with 1 will be equal to n. That's why we are equating this part to n here. Now we are taking summation of k is equal to 1 to n into k as s, because this is what we are going to find in the question. So this can be treated as 2 into s minus this particular summation n. Now just take the equation alone outside. This will be n square is equal to 2 into s minus n. Now we have to solve this. 2 into s is equal to n square plus n. S is equal to n square plus n divided by 2. Now what is n square plus n? This can be written as n into n plus 1 by 2. When we solve for s, we obtain s is equal to n square plus n by 2, which is actually expressed as n into n plus 1 by 2. What is the summation of k is equal to 1 to n with k? This is like 1 plus 2 plus till n. What is the summation of n numbers? It is n into n plus 1 by 2. So the B answer will be summation of k is equal to 1 to n, k will be n into n plus 1 divided by 2. Next problem, find summation of k is equal to 100 to 200 with k. We know the summation that runs from 1 to n is given by n into n plus 1 by 2. That is n into n plus 1 divided by 2. Now this particular lower limit is starting with 100. Usually summation series will start from 1 and run to a upper limit. Now how can we reframe this particular problem? 100 to 200 can be written as 1 to 200 minus 1 to 99. So let's take 1, 99, 100 and 200. They are asking for the sum that is between 100 to 200. Let's take this to be x. In order to find the sum that is present between 100 to 200, what we are going to do is, we are going to compute the sum of 1 to 200. So this will be something like A. And we are going to subtract 1 to 99 sum, which is B. This will give you the value of x. So this is A, this is B. Once you compute this particular sum and then subtract till here, the remaining part will give you the sum of 100 to 200 limit. So how are we splitting this problem? K is equal to 1 to 200 minus K is equal to 1 to 99. We know this will be n into n plus 1 divided by 2. So it is 200 into 201 divided by 2. So this 2 and this 200 will be cancelled and we have 100 into 201, which is equal to 20100. This is for the first case. What about 1 to 99? We have n into n plus 1. So it is 99 into 100 divided by 2. So here if we cancel 2 and 100, we will have 4950. This is for this particular summation. Now summation of 100 to 200 will give 2000 minus 4950. So the summation of 100 to 200 limit will be 15,150. Next problem and the final problem. What is the value of the following product? So far we have been adding everything. So I thought one problem can be done for product. There is a special notation for products. The product of AM plus 1 to AN is represented by this big pi symbol. J is equal to M to N AJ. The product from J is equal to M to J is equal to N of AJ. So instead of having plus everywhere, this will run with multiplication everywhere. So product means you have to multiply. So let's take two problems of this sort and solve it. First we have I is equal to 1 to 10 with 2. So what is this? For 10 times you have to multiply 2. This is for I is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 2 into 2, 4, 4 into 2 is 8 into 2, 16, 16 into 2, 32, 32 into 2, 64, 64 into 2, 128 into 2, 256 into 2, 512 into 2 will give 1024. This will be the answer. What about in summation? It will run as 2 plus 2 plus 2 for 10 times. So this is the difference between summation and product. Now what about the B sub problem? When you have minus 1 power some odd number, this will result in minus 1 because you are going to multiply minus 1 for odd number of times. When you have minus 1 for even number of times, it will result in plus 1. When I is equal to 1, 3, 5 or 99, we would have minus 1. When I is equal to 2, 4, 6, 100. So this is for the odd I value and this is for the even I value. We will have plus 1. There are 50 numbers that will give you plus 1. You need not go even this way. You know even power is going to give you plus 1. So minus 1 the whole power 100 is actually even power. This will give you plus 1. So the product is 1 for this particular B sub problem. With this we are completing this video. I'll meet you in the next video. Thank you viewers.